Hello friends, we'll be talking about parallel lines and transversal in this session. So let's first of all understand what do we mean by transversal. Transversal is any line intersecting two or more lines at distinct points. So we are saying, supposing we have these two lines and then we have another line intersecting these two given lines at distinct points A and B. This is called transversal. Two or more lines, so we could even have three lines and a line intersecting these three lines at distinct points, say A, B and C. This is called transversal line. But if we have these two lines which are intersecting at this point and we have a third line which is intersecting them at the same point, do we call this line as transversal? No, because this is not intersecting the two lines at distinct points. So this is very important when we talk about transversal. So these two examples are the transversal lines, but in this example, in the third one, this is not a transversal. So related to transversal, we'll be talking about some pairs of angles. So let's first of all draw two lines and a transversal. And we'll name each of the angles which are formed as 1, 2, 3, 4, 5, 6, 7 and 8. So we are just numbering them to make it easier for us to understand which angles are we talking about when we talk about the different pair of angles getting formed. So first set is corresponding angles. Now in this case, angle 1 and angle 5, these are corresponding angles. So we can say this and this are corresponding angles. So similarly, angle 2 and angle 6 are also corresponding angles. And angle 4 and 8 are also corresponding angles, and angle 3 and 7 are also corresponding angles. So corresponding angles are basically lying on the same side of the transversal, but they are formed with the different lines. The transversal is intersecting two distinct lines in this case. So with different line on the same side of the transversal and the line, these angles are getting formed and these are called corresponding angles. Then we have alternate interior angles. So first of all, there are interior angles and there are exterior angles. So if we look at these 1, 2, 3, 4, 5, 6, 7 and 8, we can clearly say that angle 1, 2, 7 and 8 are the exterior angles. They are formed on the exterior. And then we have 3, 4, 5 and 6 which are the interior angles. So now if we are talking about alternate interior angles, so first of all we are talking only about the interior angles which are 3, 4, 5 and 6. And we are saying alternate interior angles. So in this case, angle 4 and angle 6 is one pair of alternate interior angle, and angle 3 and angle 5 is the second pair of alternate interior angles. So these are on the different side of the transversal. 4 and 6 are on the different side of the transversal, so they are alternate interior angles, and same is true for angle 3 and angle 5. Then we talk about alternate exterior angle. Now, of course, we're talking about exterior angles now. And again, since we are saying alternate, they have to be on the opposite side of the transversal. So we can say angle 1 and angle 7 is one pair of alternate exterior angle, and angle 2 and angle 8 is the other set of alternate exterior angle. And then the last pair of angle that gets formed when a transversal cuts two or more lines at distinct points, which is called the consecutive interior angles, or they are also called co-interior or allied angles. So consecutive interior angles or co-interior or allied angles. So we are saying they are interior angles, of course, as the name itself says, consecutive interior angles. So we are talking again about only 3, 4, 5 and 6. And since they are co-interior, so that means they're lying on the same side of the transversal. So angle 4 and angle 5 are co-interior angles, and similarly angle 3 and angle 6 are co-interior angles. Now let's talk about the axioms related to parallel lines and transversal. So when the lines intersected by a transversal are parallel. See, in the last discussion that we were having about transversal, we were talking about any two lines being intersected by a single line at two distinct points, and that is called a transversal. But now we are saying that if the two lines which are being intersected by the transversal are parallel, so that which means this and this line are parallel, then we have a few axioms which will always be true. So the first axiom says, if a transversal intersects two parallel lines, then each pair of the corresponding angles is equal. So we said this and this are the corresponding angles. Similarly, we said this and this are the corresponding angles. So we are saying when these two lines are parallel, these corresponding angles will always be equal. Now why is it an axiom and not a theorem? Because this does not require to be proved, because this is obvious. Since these two lines are parallel, they have a fixed inclination, and the transversal is single, so it has the same inclination with respect to the parallel lines. So which would mean that the corresponding angles will always be equal when a transversal intersects the parallel lines. So that is why this is an axiom which does not require to be proved. And the converse of the axiom is, if a transversal intersects two lines such that the pair of the corresponding angles are equal, then the lines have to be parallel.
Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.